All right, the people, welcome back. And now we're looking at question number 5, and we're going to start with question 5.1. This question is about the structure and bonding. Figure 5 shows part of the structure and bonding in diamond. Explain why diamond has a high melting point. All right, so first thing that we got to keep in mind is that diamonds are made of carbon. So each one of those there is a carbon atom. In a diamond, each carbon connects to 1, 2, 3, 4 other carbons, okay? Now, another thing that we need to remember is that this whole shape here is called a tetrahedral shape, okay? Okay, there we go. So that's a tetrahedral shape. Now, we also know that because every single one of those carbons is bonded to each other, that must be covalent bonding. Okay, here we go. So just writing down a few facts about carbon and in the diamonds, okay? Now, explain why diamond has a high melting point. Well, first of all, one of the answers is here, okay? Diamonds are made with strong covalent bonds, okay? Diamonds are made with strong covalent bonds. Now, your second mark is going to be that there are millions of strong covalent bonds in the diamond because diamond is a giant covalent structure, okay? So that's 2 marks right there. And the third mark is that because the covalent bonds are really strong and you got millions of them, you're gonna need a very high amount of energy in order to break those bonds and disrupt their shape in order for them to melt, okay? And that is the reason why diamond has a high melting point. So let's write those 3 answers right now. So there you have it, 3 marks. Diamonds are made of very strong covalent bonds. Diamonds are giant covalent structures that contain millions of these covalent bonds, and then large amounts of energy are needed to break those bonds for diamonds to melt. That's why they have such a high melting point, okay? So let's go quickly to question 5.2. Question 5.2. Figure 6 shows part of the structure and bonding in sodium chloride. Okay, so we have your molecule, you have your chloride ions, and you have your sodium ions as well. Explain the conditions needed for sodium chloride to conduct electricity. Now, this is one of the easiest questions you're going to get as well, okay? Now, first of all, we know that chlorine is a nonmetal, and because it's an ion, those chlorines are going to have negative charges, okay? So those are all negatives. Now then, sodium ions, sodium is a metal, and metals always give away their electrons and they become positive. So those are all positive ions, okay? So now I've got a structure, a giant lattice, a giant ionic lattice made of positive ions and negative ions, okay? So just put a pin on that for now. So electricity essentially is the movement of a charge or current, okay, through a medium. That could be a liquid or it could also be a solid. Now, electricity can only be conducted by 2 things, and that's gonna be free electrons or free ions, okay? And by free, we mean that they are able to move, okay? So let's make a note of that. To conduct electricity, okay, that's the first idea that we gotta keep in mind. Now, this sodium chloride has ions, but are they free or are they stuck to each other? Exactly, because they are bonded with each other. That is an ionic bond, that's electrostatic attraction, and an ionic bond, and so on and so forth. So those ions are not free to move because they are in solid state, okay? Now, because they are in a solid state, they cannot conduct electricity. But it says explain the conditions needed for sodium chloride to be able to conduct electricity. Now, in order for the sodium chloride to conduct the electricity, the ions need to be able to move, okay? You need to have free ions. And the only way that you're gonna get those to move is by doing two things. Either you melt it and turn it into a liquid, or you dissolve it in water so that the ions can actually move. If you dissolve it in water, the ions will move, and if you turn it into a liquid, the ions will also be able to move, and then you can conduct the electricity. That is your answer for it. Simple as that, okay? So let's write it down. All right, so there you have it. Easy peasy 3-mark question, okay? So let's move on to question 5.3. Question 5.3. Figure 7 shows the structure of sodium. Okay, so that is sodium and that is a metal. Describe how sodium conducts thermal energy. Now, when talking about thermal, we're talking about heat. Okay, talking about heat energy. So remember that we said that in order for electricity to be able to be conducted or transferred, they need to be free ions, cations or anions, or they need to be delocalized electrons or free electrons. Now we know that sodium is a metal, okay? And metals will have a sea of delocalized electrons. So you're gonna have electrons all over the structure that are free, they're moving, they're not stuck in one place, and they can conduct the electricity, and that's why metals conduct electricity. Those electrons are able to move all over the place. Now, the thing is that they don't only conduct electricity, they can also transfer heat, okay? So when one of these lots is getting a lot of energy, and I'm just gonna make it vibrate a little bit more, that energy is passed on to the next electron, to the next electron. As they move in faster, they collide and they transfer that energy from one electron to the other. And before you know it, all those electrons are moving super quick, and they are transferring that energy all across the structure, okay? Eventually, that energy becomes strong enough to disrupt the position of the atoms, which makes them lose their shape, and therefore they turn into a liquid and they melt, but that's only if you conduct enough of it, okay? But essentially, they're just asking us to describe how sodium conducts thermal energy, and that is your answer right there. So let's just write that down. So there we have it. Now, when we're looking at the mark scheme itself, it's telling us that we need to avoid saying it conducts thermal energy, ignore electricity. So you want to make sure you refer to it as transferring energy throughout the structure, okay? We do know that technically they are transferring thermal energy. We do know that they conduct electricity, but specifically you want to mention that they are transferring energy around the structure, okay? That is the correct way of wording this down, because otherwise you may not get the marks, even though you know what you're talking about. It's just the wording that needs to be a little bit more specific, okay? Now, I recommend you guys to get familiarized with the way that the questions need to be answered by looking at the mark schemes, okay? So what you need to do, you have a go at the exam papers, mark them yourself, make corrections, and then that way you get used to the language, the accepts, the ignores, the whatever is in bold has to be included, or whatever is underlined has to be included. If something is in brackets, is optional. So you need to make sure you understand all of these bits about how the papers are marked, okay? So that was question number 5, and click on the next video so we can have a look at question number 6. Peace out. Right, so there you have it. A quick time revision. Like and subscribe, and I'll see you next time.